Hi, this is Mrs. Slater, and today we're going to talk about 1.7 exponential notation. So our objective today is to use integer exponents. So for example, in exponential notation, we would write things like a to the n. A is the base, while n is the exponent. Okay. Examples would be if we say 3 to the fourth, we know that that is 3 times 3 times 3 times 3, and it's a total of 4 times, and then we can evaluate that to get 81. So it's just a different way to look at 81. Okay? Okay, so what if we have negative exponents? How is that going to affect our number? So we'll start with something with positive. We know that 10 is 10 times 10 times 10, which gives us an answer of 1,000. And 10 squared would be 10 times 10, and that's 100. And 10 one time is just 10, so that's going to be our answer. 10 to the 0, if you look at the pattern, see how it automatically eliminates a 0 every single time? Well, this is what happens when it always is set equal to 0. Your answer will be 1. So make yourself a note in your notes. Any base number to the 0 power equals 1. Okay, put that in your notes, please. Okay, so then the pattern should continue, and when you see the negative number, it means that it would be 1 over 10 to the first power, which is just 1 over 10. Okay, same with the next one. It would be 1 over 10 squared, which is 1 over 100. And then the next one would be 1 over 10 to the third power, which is 1 over 1,000. And then the last one, 1 over 10 to the fourth, is 1 over 10,000. So the 0 just would increase in quantity in the denominator. So those are your answers there, and hopefully you get a better idea of why you have negative exponents and what it does to the graph, to the answer. When simplifying, there are certain rules that you should remember. So in simplifying something like parentheses, negative 6 squared, keep in mind that the squared is on the outside, so it would be negative 6 times negative 6, because there are 2 of them, to give you an answer of 36. Okay, and then on the other hand, that was example 1, so example 2, on the other hand, what if you have no parentheses? Well, order of operations says that the only thing that squared is attached to is the 6. So you're really multiplying a negative, and then you're multiplying 2 6s together, which gives you an answer of negative 36. So be really careful with your parentheses. Also with variables, that's another way you can simplify. If you have 4x squared equals, if you want to evaluate this, you would have 4x multiplied together 2 different times, and then you would multiply the numbers together and the x's together, because multiplication is commutative. 4 times 4 is 16, x times x is x squared for your final answer. Okay, on the next ones I want you to try is negative 3m to the fourth. Go ahead and push pause and see what you get as an answer. So it's 4 times, and it's all in parentheses. So hopefully you wrote negative 3 in parentheses 4 different times. And when you multiply negative 3 times negative 3 times negative 3 times negative 3, you end up getting 81, because those negative times negative is a positive. And same with the second set. This is 9, this is 9, and this is 9. 9 times 9 is 81. Now with the m, it's the same thing. Now I ran out of room, otherwise I would put everything horizontally. and then that would be m to the 4th, so for a final answer of 81, m to the 4th. The last one I want to do is has a little more information here. So if we have 9 times 3y to the 3rd power, often a temptation is to take the exponent of 3 and also attach it to the 9, but that is not the case. 9 is just going to tag along for the ride, and 3, that exponent of 3, is only attached to the 3y, so that is what will be listed 3 times, not the 9. Okay, so then if we multiply 3 times 3 times 3, you get 27. Y times y times y, you end up getting y to the 3rd. And then when you multiply those two together, and after multiplying 243, you get for 9 times 27, and y to the 3rd would also be part of your answer. So in general, you have different properties of exponents. The first one is anytime you have any numbers or letters inside of parentheses and a power on the outside, a times b could also be looked at as a to the m times b to the m. So an example of that is if you have 2x to the 3rd power, which we just practiced. You have 2 to the 3rd power, and you have x to the 3rd power. So you get 8x cubed. Okay, the next one we talked about with the chart of 10, a to the 0 power, anything to the 0 power, is 1. So I'm not going to do an example on that one. The next one also was in that chart, but again in generic form. Anytime you want to get rid of a negative, you can take 1 over that particular base and that exponent. Notice that the exponent is now positive. Same thing for a negative in the denominator. If you want to make that positive, we can move it up to the top. So it's a to the m for your final answer. And then one last thing I want to write down is a couple examples here. If you had 7 to the negative 2, another way to write that is 1 over 7 squared, and we all know that 7 squared is 49. So that's how you can simplify using exponents. And then this last one, I want to also give you an example. What if it's 1 over 16, I meant 6 to the 3rd, or negative 3rd power. Okay, and if it's 6 to the negative 3rd power, we can move anything that has a negative exponent into the opposite part, so it'd be 6 to the 3rd, and then when you multiply that together, you get 216. Okay, and then finally, if you have a division and an exponent on the outside, that means that you can set both of them to that exponent. So a to the m over b to the m. An example of that is 2/3 to the 3rd power. So 2 to the 3rd and over 3 to the 3rd is the exact same thing as 2/3 to the 3 power. But it just makes it easier to simplify. So you get 8 over 27, and since that does not reduce, that's going to be our final answer. Okay, so I just want to do a few more examples to help you understand the concept of everything about exponential notation, and a lot of pushing pause here. So let's go with a new set here. Example number 1, if you had negative 9 to the 2nd power, go ahead and push pause and solve. Okay, so we know that's negative and then 9 times 9. So you should have gotten a negative 81. Remember, the 2 is only attached to the 9, not the negative sign. All right, go ahead and push pause for this one. This one is a negative 7 squared. This time there's parentheses. Push pause and solve. This one is negative 7 2 times, so therefore negative times negative is a positive 49. Okay, the next one, we're going to write an equivalent expression without negative exponents. No negative exponents. So keep that in mind when you're looking at your final answer. So number 3, I want to begin with 5 to the negative 3. Okay, so if we're going to get rid of the negative sign, go ahead and push pause and try it. You should get 1 over 5 to the 3rd, and when you simplify it, 1 is going to be over 125 for your answer. So hopefully you got that. More with negative exponents. What if we have a to the 3rd, b to the negative 2 over c to the negative 4, and d to the 7th. Okay, lots of different things going on there. And if we want to get rid of the negative exponent, we're going to have to move this one in the denominator, and we're going to have to move this one into the numerator. So what that's going to look like as a final answer is a to the 3rd, c to the 4th, and b to the 2nd, and d to the 7th. Okay, so I want you to go ahead and try this one on your own. X to the negative 4, y to the negative 7, z to the 3rd over a to the negative 2, and b by itself. Push pause, solve. Okay, so you should get, let's turn the page a little bit, you should end up with this one in the denominator. There's a negative, so that's going to be in the denominator. And then this one is negative, so that's going to go in the numerator. So if it's confusing, go ahead and pause and rewind and see if you can understand that a little better. But anyway, so we have x to the 4th. I move that down to make it positive. The y to the 7th, I'm going to move that down. Hold on while I erase this really quick. Did not need to put it up in the top. Okay. So then z to the 3rd is okay right where it is because it's already positive, and b is also positive, so it's okay where it is. So the only thing left is to put an a squared at the top. So good job if you got that right. And let's go ahead and go on to the next problem. Number 6. This one I want you to do is a negative 3 x to the negative 2. Go ahead and push pause and solve. There's a cleaner version for you. And then everything should have a negative 2 on it. So negative 3 would be to the negative 2 times x to the negative 2. Okay, so now with that, alright, so to get rid of the negative exponent, 1 over negative 3 squared. Notice I'm keeping my parentheses. And the next one would be x squared. Okay, I'm keeping the parentheses on the first one because it is a negative sign, so you have to be really careful with those. And then the finale here, it's 1, because 1 times 1 is 1. And then negative 3 squared is positive 9, and then x squared. That's going to be your final answer. Alright, so let's just do a couple more. This time I want you to write it using, we're going to use negative exponents this time. Okay, so if we're using negative exponents, example 7, I want you to do is 1 over 2x squared. Okay, so with this one, we're going to move everything at the top, and you can keep everything in the parentheses and just make it 2x to the negative 2, keeping those parentheses in there. Okay, the next one I want you to do is also just use negative exponents. So if you had 3 over 5x to the 3rd, what would that be? Push pause, see if you can try that one. Okay, so you should get 3 times 5x to the negative 3. The original 3 is not going to be affected, so really I don't need this little line here anymore because it's all over 1. Okay, and then I think that's about all we'll do for today. Thank you so much.